My name is L. Baba Fakhruddin. I am from CSC. My topic is Otto cycle working process and CI engine. First, we know the presentation of Otto engine. We see the diagram. Next, content. Introduction. What is Otto cycle? Otto cycle processes, work, thermal efficiency, and applications. Introduction. In 1876, a German engineer, Nicholas August Otto, built first working four-stroke engine. A stationary engine used a coal gas air mixture for fuel. The cycle of the Otto engine is called the Otto cycle. It is the one of most common thermodynamic cycles found in automobile engines. It is a typical spark ignition piston engine. What is Otto cycle? Because of complicated analysis, some assumptions are made. The main assumption is that the working fuel is ideal air and heat is transferred by heat reverses reservoir. So this cycle known as air standard cycle. Otto cycle consists four processes. Two are constant volume isochoric, two are isentropic process. In this cycle, heat addition is done at constant volume process, so this cycle is also known as constant volume cycle. Otto cycle process. Isentropic compression. The gas is compressed adiabatically from stage 1 to stage 2 as the piston moves from bottom dead center to the top dead center. The change is in volumes and it's the ratio V1 by V2 is known as the compression ratio. Isochoric compression. Ignition phase. In this phase, heat transfers to the air from an external source while the piston is at rest at top dead center. This process is intended to represent the ignition of the fuel air mixture injected. The pressure rises and the ratio P3 by P2 is known as the explosion ratio. Isentropic expansion. The gas expands adiabatically. The gas does work on the piston and force it to move to the bottom dead center. The volume ratio V by 4 V by 3 is known as isentropic expansion ratio ration, but for Otto cycle it is equal to the compression ratio. Isochoric decompression. In this phase, the cycle completes by a constant volume process in which heat is rejected from the air while the piston is at bottom dead center. The working gas pressure drops instantaneously from point 4 to point 1. The exhaust valve opens at point 4. At the end, the exhaust valve opened, the gaseous mixture is vented to the atmosphere. We see the diagrams. Intake. Air is coming from the engine, fuel, piston, compression, power, exhaust. Next, work. During the Otto cycle, work is done on the gas by the piston between state 1 and state 2. Isentropic compression. Work is done by the gas on this piston between stage 3 and 4. Isotropic expansion. The difference between the work done by the gas and the work done on the gas is the net work produced by the cycle, and it corresponds to the area enclosed by the cycle curve. We know the thermal efficiency for Otto cycle. In general, the thermal efficiency nth of any heat engine is defined as the ratio of work it does W to the heat input at the high temperature QH. Eta equals to W by QH equals to QM minus QC by QH equals to 1 minus QC by QH. Q add equals to MCR of T3 minus T2. Q out equals to MCR of T4 minus T1. where equals to 1 minus T4 minus T1 by T3 minus T2 gives rise to eta Otto equals to 1 minus V2 by V1 whole power eta minus 1 equals to 1 minus 1 by CR power n minus 1. Applications. Common cycle used in internal combustion engines. Otto cycle 4-stroke engines are commonly used in most cars and trucks today. Thank you for watching this video.